for sharing your ideas. And I'm looking forward to the go-to solution, because recurse of course stresses the return stack, and we will see. Yeah, great. Thank you very much. And then we conclude this meeting with Brad Nelson's session on ESP32Forth, and we're looking forward to the news that Brad can tell us.
All right. I've got only one bit of news. An interesting API that I decided to make some use of in connection with ESP32Forth. So there's this new web API that will allow me to pull the magic trick of proposing that, assuming you have the Chrome browser in your computer, you may already have a serial terminal that you can use. What this is that about 2021, a new API got introduced that allows reading and writing to serial devices, USB devices, Bluetooth serial devices, so anything that sort of behaves like a serial port. This API is unfortunately Chrome only. Other browsers like Safari have not adopted it, although I think it may be an Edge actually also. It's a Chromium-derived browser. And then what it does is it provides a method for you to pair with a device and then do asynchronous I/O with that device. It's sort of typical of contemporary web APIs. It uses a concept called promises that if I can get a mind to at some point, I've often wondered what these would look like in Forth. But the idea is that you can request pairing with a device, and it returns a promise to sort of wait on the on that operation to complete. And then after that, you can check to see if there are any devices that have been granted permission to interact with your particular website. And then you can open a port and then get a reader or writer object. It's very object-oriented interfaces, and then do an asynchronous read or write using an array buffer, which is another JavaScript concept that lets you deal with raw bytes. So I wanted to add this into the web version of microeForth, which is the Forth that powers ESP32Forth. And the web version has the ability to inject little chunks of JavaScript in what is called a raw string. So it starts with this little R tilde. And then what I do is keep track of the set of data that is in a buffer headed to the serial port, from the serial port. And then I keep track of the set of current ports connected, and then I pick one of them to be the active port. And then I also keep track of the current writer that can be used to send bytes. And then there is this concept of an async function that has been introduced in the last many years ago now to JavaScript, which is something where it will operate, and then whenever it gets to an operation that is asynchronous, it will sort of yield control back to the main event loop. And so you can do an await operation to open a port, and you pick the baud rate, although with the serial API, what actually happens is this is just a hint. And so if you've got a USB serial device, for example, it will typically auto-select the baud rate and happily disregard you if there's something on the other side of it that wants another baud rate. And then I open up a writer so that I can later on send bytes to it. And then I create this event pump, which just gets a reader from any of the active devices, attempts to read a single byte, and then, apologies, sorry, not a single byte, a chunk of whatever length, and then it checks to see if this particular reader is done, meaning it's sort of gotten a break in the connection. And then if it is, it releases the internal lock on that reader. And then I feed all of this data into a buffer. I also have an operation to scan for updates. There are a couple of events that can cause changes in which serial ports are present. So I'll check to ask for a promise for the set of ports, and then the then operation lets you sort of continue once that promise has completed. And using that set of ports, I will update those state variables that I mentioned before, and then call this prior route serial operation to create a pump. And so the net is that this buffer will contain inbound bytes, and this writer will be available to send bytes outward, which is ultimately all I want to plummet into Forth. One more thing I do is I register some listeners to do this update serial operation whenever something changes about the connections of the serial ports. And then finally, for the web version of microeForth, there is the ability to define words in JavaScript. And I believe I only need 3 words, is it? I'm forgetting now. So one is pair serial, which does the operation of attempting to do a pairing operation with a device. The reason they have this pairing step is you don't want a random website that you go to be able to just decide to access your serial port. That would be dangerous. In fact, that as I understand it from knowing folks involved in web browsers, that danger, even in the case where you have agreed to it, is one of the debates in exactly how to have it look that kept this API from prime time for a long time. And then I have a word that is this probably unnecessarily verbose serial key read raw, which reads a single byte from a serial port or -1 if there is nothing available. So it's a non-blocking word. And then I have serial type, which can send a whole buffer out to the serial port, or it will happily swallow the data if that data isn't available. And if folks are ever tinkering with the web version of microeForth, it sort of demonstrates an interesting thing about defining words in JavaScript in combination with Forth. You can pass in locals and then reference them in the JavaScript code. And then using these, I'm able to create a Forth pump that pauses to yield to anything else going on in the system, checks to see if there is a character available from the serial port. If it is, it emits it to the terminal. Otherwise, it drops the -1. And then it checks to see if there is a key from the user, and if there is, it reads that into using some excessive magic here to read that value into the return stack, which I use as a temporary buffer to then call type, and then I clear out the return stack. And so this essentially is just redirecting serial input to the Forth output device, whatever that happens to be, and the input device to the serial port. The web version of microeForth can be embedded in a web page just by including a single JS file, and then you can have scripting tags in Forth. So I'm able to build a very simple serial terminal. I have a yes/no word that waits for a single key, and if it's yes, it returns true and otherwise false. All of those words that I mentioned previously are inside of the web vocabulary. So I activate that vocabulary and then define a word called go that prints out, hi, I'm a serial terminal, asks if you want to pair. If you do, then it pairs. Otherwise, it goes into that infinite pump. I switch back to the Forth vocabulary just out of neatness, and then go ahead and run. So now I'm going to switch over and demo it. For the purposes of the demo, I've got a device. I've got a couple devices here, but one that I can't say I recommend particularly. It's the T dongle S3. It's got an ESP32S3. Here's the actual device on a little stick. Ooh, and I dropped it. It has a little display, and two things about it that I don't particularly care for, but I'm using it for the demo because it's easy to carry around. One is that it gets very hot when plugged in for reasons that I can't really fathom. The other issue is that the head I've had to super glue because after being inserted and removed several times, it's fallen out. So in any event, let me, so this functionality is available, on the ESP32 website. I'll do this sort of two ways round. One, let me shrink the font. So actually that's probably reasonable. Okay, so little known thing here, when you are on a website in Chrome, there's a bunch of options under this little icon that shows you things about the site. And so the first thing I'm going to do is I'm going to insert this this device into the serial port, and then I'm going to do I'm going to go into that web vocabulary I mentioned, and then I'll do pair serial, and it pops up this dialog, noticing that and shows the one device that's there. If there are several devices, you could choose which one to connect to, and then you can connect to it. And then after that, if I do this serial pump, I'm now talking to the serial device, and I don't know. Let's see, to demonstrate that I can do an LS on the SPI file system. If you now remove that device, it will be broken. The connection is broken, but it is fairly smart about reestablishing the connection, and you can use it. You could have several devices, although it will just favor the first that was connected. To make it easy to use the steps that I've just shown, there's a currently undocumented thing at eforth.appspot.com/serial that sort of offers to pair. I'm going to stick in this second device. I've got a bunch of random ESP32s on a board here, and I will go ahead and say pair, and now it's offering me two options. It knows that this one's previously paired, so I'm going to pick the second one, and then now I've got this older board that's got some earlier version of things running on it. If you wanted, if you click on the icon that I mentioned before, you can see that associated with this web origin are these two devices, and so these two have been granted permission to interact with it, and you can revoke that permission, this little X, so I'm going to remove this other guy, and I'm going to reload and show one other thing. So I'm not going to pair this time because I already had a device connected. And in ESP32Forth, even I've got these terminal words defined, so you could interact with a color terminal. And this is a color terminal, which is nice. You can do things like, print out, and I'll go back to the normal color and the character terms. You could define something like that and see a bunch of colors. You'll remember that there's a visual editor on the ESP32 as well. I can use it to open up so it's in the visual vocabulary, and then edit expects one word after it with the path. So I'll open up this file, and this terminal can interact with, this understands the appropriate escape codes to be able to print this terminal. It is not a full. It's a very narrow subset of VT100 with a couple of the extensions for color, but by no means everything is in there. And that is it. Are there any questions?
My question would be, how do you set the baud rate?
So currently I am leaning heavily into the assumption that the device connected will be a USB serial device and will not care what the baud rate is, but it is a fair point that I probably should have that option exposed somewhere. Right now it is baked in that it is 115200.
I see. Yeah, thank you.
Is there a way to have a serial device interact with eForth? So in other words, you could connect to a serial device out in the field and have it send data to the eForth interface?
So in principle, so if we go back to the web one here, and maybe I'm not getting at make sure I've got your question right around. So the web version, after you've paired with a device, although in this example, that's not what I wanted to do. In this example, I just have this serial word, which is like a pump. If you wanted instead to actually interact with the device and send it, you could send it, particular serial operations of your own choosing. So I happen to have just set this up as a bidirectional terminal to the display, but you could just send raw serial writes or reads to it. Does that answer your question, or maybe I wasn't quite getting?
Yeah, I believe so. That would be very interesting to be able to have a UE4th engine that interacts with serial devices out in the field somehow.
Yeah.
And then follow on would be, how would this relate to like WebAssembly, WASM, which is the assembled version?
So it's not directly related. I mean, I guess WebAssembly is a sort of a separate mechanism in the browser. There is a very indirect relationship in the sense that the web version of Micro eForth internally is written so that it emits an ASM.js piece of code, and it happens to be I used to work on Chrome, and it happens to be the case that internally that will get converted to a WebAssembly module, but that is just an implementation artifact. WebAssembly is the way to think of it is that it is a set of web APIs that allow you to run low-level code on the web. It doesn't provide direct low-level access to devices. So for that, you have to rely on other APIs in the web, and Webserial is one. There's also a Web USB API that's recently come out, and so typically with WebASM, you're needing to interact with the outside. There are versions of WebASM that run outside of the browser, and that's a whole another more complicated story. But
very nice, very nice.
So I encourage folks to try it out. If you've got Chrome on your device and you go to the URL I put in here, you can use it. If you've got some serial device to hook it up to, you have one more serial terminal, and this will save me the trouble in the future. I often use the PuTTY. PuTTY can act as a serial terminal, and this is sort of one step easier because now it's one less thing to install.
Right. Well, thank you very much. Are there any additional questions?
Not a question, but I am impressed every time I see Brad's efforts to extend all the features we have in ESP32Forth. This is why I use it, because it's so it's so useful for me, and it's easy to program. When I see force from other developers, I never tried Travis, but I have a lot of positive comments about Travis' work. I'm not using the Raspberry Pico because I don't have so much time for many platforms, and ESP works for me. So I keep working with that. And now is Peter Jackeke adding to the effort of Brad. You all know how prolific Peter Jackeke's work with Tachyon is and how fast. And he has a lot of knowledge from the industry. Peter develops his boards and installs at customers. We always talk with Peter with the same, we are in the same page. We have the same view that Forth is the best, one of the best languages and one of the best philosophies for embedded systems and to solve problems in the real world. We work in the real world. We are not theorists. We are not making theory about languages. We solve every week problems for customers or problems for ourselves in the case of a hobby. And the work of Brad in that aspect is brilliant. I can edit, I can use the assembly, which is inside of the chip. I don't need external tools. I don't need Bluetooth, which we need in C and other languages. So I need to say it's super important and super useful.
Yeah, thank you for the comment. I appreciate that. And thanks also, Brad, for all the effort you put in that. So it's always amazing how great the system progresses.
Thank you for the kind words.
Also, I want to say something very shortly to Bill. Is Bill on the meeting now? He's gone.
Mm-hmm.
Both Brad and Bill Ragsdale are presenting always at the SVFIC meetings, as you probably know. And I asked them, no worries, come to our meeting and duplicate your presence on video, because probably on SVFIC you reach one kind of people, and probably also you find new people here on our Zoom. And in any case, we both sent this to YouTube channels. Both channels are very successful in the moment, SVFIC as Forth 2020. So we reinforce the presence of Forth on the web.
Right. So I think
Christian has a question, Ulrich.
Christian.
Yes.
The question. Go ahead.
Did someone say that I had a question?
Yes,
No,
I said.
I don't have one.
Wow, that's a surprise. That's a surprise. Yeah, anyway. So that's something to celebrate. I think this concludes our meeting for today. We keep the conference running on and let it run, but I will just stop the recording. So thanks everyone for watching this later on YouTube, for staying with us, and see you next time.
Thank you.